To calculate the voltage drop for a three-phase Y system, you'll need to follow a series of steps. These steps involve determining the line resistance and reactance, calculating the neutral resistance, finding the current in the neutral, and finally, computing the voltage drop. Let's break down each step with the formulas and an example. Firstly, calculate the line resistance and reactance for each feeder. The conductor resistance, denoted as R, is calculated using the formula R equals ρ times L divided by A, where ρ is the conductor resistivity, L is the conductor length in feet, and A is the conductor cross-sectional area in circular mils. For copper, the resistivity ρ is approximately 10.37 ohms circular mils per foot. The conductor reactance, denoted as X, is calculated using the formula X equals 2 times pi times F times L, multiplied by the quantity mu sub 0 divided by mu sub R, and finally multiplied by 1 divided by D. Here, F is the system frequency in Hertz, mu sub 0 is the vacuum permeability, which is 4 times pi times 10 to the power of -7 Henry per meter, mu sub R is the relative permeability, which is 1 for copper, and D is the conductor diameter in feet. Secondly, calculate the neutral resistance. For the neutral conductor, the resistance, R neutral, is calculated similarly to the conductor resistance using the formula R neutral equals ρ times L divided by A. The same resistivity value for copper is used, and L and A refer to the length and cross-sectional area of the neutral conductor. Thirdly, calculate the current in the neutral. The neutral current, denoted as I sub n, is calculated using the formula I sub n equals I sin theta divided by the square root of 3, where I sin is the sum of the phase currents in amps and theta is the power factor angle in radians. Fourthly, calculate the voltage drop. The voltage drop per phase, denoted as delta volts, is calculated using the formula delta volts equals the quantity 3 times I times R plus 3 times I times X. The total voltage drop, delta volts total, is then calculated as 2 times delta volts. Now let's apply these steps with an example. Given a 120/208 volts line, a current I of 350 amps, a conductor length L of 200 feet, a conductor size of 500 mcm, a ground conductor size of 1/0, and a power factor of 0.8, which gives a theta value of arc cosine of 0.8, which equals approximately 36.87 degrees. Let's calculate the voltage drop. Firstly, calculate the conductor resistance. R equals 10.37 times 200 divided by 500,000, which equals 0.415 ohms. Secondly, calculate the conductor reactance. X equals 2 times pi times 60 times 200, multiplied by the quantity 4 times pi times 10 to the power of -7 divided by 1, and finally multiplied by the quantity 1 divided by 0.528, which equals 0.321 ohms. Thirdly, calculate the neutral resistance. R neutral equals 10.37 times 200 divided by 105,590, which equals 0.197 ohms. Fourthly, calculate the neutral current. I sub n equals 350 times sine of 36.87 degrees divided by the square root of 3, which equals approximately 200.7 amps. Fifthly, calculate the voltage drop per phase. Delta volts equals 3 times 350 times 0.415 plus 3 times 350 times 0.321, which equals 10.27 volts. Finally, calculate the total voltage drop. Delta volts total equals 2 times 10.27 volts, which equals 20.54 volts. Therefore, the voltage drop for the given system is approximately 20.54 volts.